Okay, so today's lesson is on graphs of relations and functions. And before we start with looking at these two graphs down here, I wanted to just review some important vocabulary from a previous lesson on discrete data and continuous data. So discrete data are data that can only take a finite number of values. And my example here is the number of people on the bus. So when I'm looking at a graph of discrete data, I might just see dots. There's the number of people on the bus over time, for example. Whereas continuous data can take any value. So all the spaces that are between these dots in this graph could be connected like that. And here, in this case, I have dots. And down here, I have a smooth curve or line. So that's going to be important in what we're going to look at today. So let's start off by recording the coordinates of these points that we see here on this graph. So -2, 0, -2, 0 is the first one, -1, 1, 0, 2, and this guy right here, 1, 3, 1, 4, and 1, 5, and then 2, 6. So we're going to look at two things. Notice in our coordinates, which really could be a table of values if I drew a line down here and wrote x and y, notice that for these three values of x, which are the same value, right, that is an element of the domain, is associated with 1, 2, and 3 elements in the range. Remember that this is my domain here, these values, and this is the range. So because that 1 is associated with more than one element from the range, in this case 3, 4, and 5, this is a relation and not a function. And the other way we can tell that, if I don't have this table of values or I don't want to write out all those numbers, if you look at this graph, you can see right here there's a vertical line at 1, and you can see that it goes through this point and this point and this point. And so that is, down here, our vertical line test for a function. So I pass a vertical line in my head, just imagine it, I move it across a graph, and if it touches the graph in one spot as you pass it along, then it's a function. So if it only touches it in one spot the whole way along, then it's a function. If it crosses more than once, then it's only a relation. So if we go back now to this graph over here and just zoom in so we can see it a bit better, you can see, again, if we write out the coordinates, so this would be down here at -3, -1, and -2, 0, -1, 1, this point, 0, 2, 1, 3, and 2, 4. You can see two things have occurred here. One, if I look at all of my x values and y values, there are no repeats in the x. There's no domain value that's associated with more than one range value. And also in the graph, you can see if I pass a vertical line, so there it touches it once, and I'm moving from left to right once, there the line is actually on. You can see with those dots going vertically down at x equals 1 here, and then that value there. So this is a function. It passed the vertical line test. So this is a function. This over here is a relation because it did not pass the vertical line test right there. All right, just a bit of review of what domain and range are. So domain, the set of real numbers that can be taken by x. And in a table of values, it is the first column. So if I have a table of values here, this are x, these are y, this is my domain right here, and this is my range. And the range, the set of real numbers that can be taken by y. and it's the second column as I illustrated up here. So remember when we're looking at a graph that this is the x-axis, the horizontal one, and this is the y-axis. And so again, here's x and here's y in these two. And we're going to do two things. In each of them, we're going to decide, is it a function or only a relation? So remember that both of these graphs are relations. Everything can be a relation, but a function is a special type. So I pass that vertical line in my head from left to right across this graph, and you can see that it does not touch the graph more than once. Whereas on this side, over here, as I pass that line across, it touches twice there, it touches 3 times here. So this is a relation. It did not pass the vertical line test, as you can see there. And this is a function. And now if I do the same test down here, pass that vertical line across this graph, what happened? Well, hopefully you saw that this is a function as well. This is a function. But here, if I pass that vertical line across this graph, you can see in number of places it touches it twice. For example, there, and there, and there, and in a number of spots. So I'm just going to get rid of all that. All right. Now, the second thing I wanted to do with these was state the domain and range. And you can see, if we go back to that idea at the beginning of the video about discrete data, these are discrete data because I have dots. So I just link the idea of discrete and dot. Whereas these two down here are continuous. I have a continuous line or curve. All right. So the way that I'm going to do the domain and range for each is different. When I write the domain, I'm going to use these kind of brackets, which we call braces, I believe. And the domain is the x values. So if I start on the left, so I go from left to right, you can see my first value is here at -7. So I write -7, comma, then -5, then -4, -2, 1, and now I'm over here at 3, 4, and 7. 3, 4, and 7. And close it off, and that's my domain for this graph here. And then my range, now I'm looking at the y values. And I'm going to go from the bottom up. So you can see my first value is, and I'm just going to clear off some space here so we can see what we're doing. Get rid of that. You can see my first value is at 1 when y equals 1. And then 2, over here 3, 4, 5, 6. And that would be the range for this graph. Let's go down here and look at these, because this one here would be very similar to do domain and range. It's just a list of numbers. All right. Now, when it's continuous, what I want to be able to do here is identify for x, my domain, what is the lower limit of the graph and what is the upper limit. And by that, I'm really just saying where does the graph begin on the left and where does it end on the right. And so if I look at this graph here, you can see that I have a definite end to it right there at x equaling 9. But this end over here does not have a point on it, so that tells me that this continues going up and to the left to infinity. So for my domain, I really don't have a lower limit because this keeps going in the negative direction for x. It keeps going along this way, so I don't really have a lower limit for x. So what I do then is get rid of this. That's gone. And now I think about, well, where's my upper limit Well, it's right here at 9. And so what my domain here is saying is that x is less than or equal to 9. And that makes sense because on my graph x can be 8, x can be 6, 4, 1, -5, and so on. So it's all values less than 9 or equal to 9. That's my domain. And now if I clean this up a little bit so I can see it again, when I'm thinking about the range, I do the same thing for y, except I'm looking for where does it start at the bottom. So again, my lower and my upper values. And you can see if I start from the bottom down here and I start going upwards, the graph begins right there at y equals 0. So my lower limit for y is 0. And although it ends here on this side, you can see that's at 5 there, but you can see that at 6 the graph still exists over here, and at 7, and at 9, and beyond. So this one, that upper limit, I'm just going to get rid of that and say there is no upper limit. And the other thing I want to include here is a little comma and say y is an element of the real numbers. And so this is the Greek letter epsilon, and this funny r with 2 backs means the real numbers. And that's my domain. And I should really have included that up here with x as well and said x is an element of the real numbers. So now look at this one. And maybe this would be a good point for you to pause the video and decide what are the lower limit and the upper limit for x and y. Where does the graph begin and end? Okay, well, hopefully you saw that it begins here at -9, and as I go to the right, it ends at -1. And those are the x values. So I just put them in here, -9, -1. And x is an element of the real numbers. What does that mean? It means that this is a continuous curve. It's not discrete data. And now if I look at the y-axis, the y values, I can see that my graph begins at 1 and ends at 5. So 1 and 5 are my limits for this graph. Okay, now, there we go. What was the difference between the first 2 graphs and the last 2? Well, I pointed that out. The first 2 graphs were discrete data, so they were dots. And that tells me that the domain and range will be a list of numbers. And that's all, the list of the values that x takes for the domain. Remember, x is domain, and the list of the y values for the range. The last 2 were continuous. And so when I have a continuous curve, my domain and range are a little bit different. Domain is what 2 values does the graph exist between for x and for y. So over here, I've got these 2 graphs, and I'd like you to try and do the domain and range for them, and then I'll give them to you, and you can see if you got it right. Okay, so the domain for this first one, for A, you can see that this line, there's no dot. That means this is going to continue going up and to the left. I have no lower limit, so I'm going to get rid of that. And when I'm saying lower limit, that has a meaning later on in math that you'll learn limit. I'm just saying where does the graph begin and end. Anyway, the upper limit where the graph ends on the right is at 3. So for this graph, x is less than or equal to 3, a comma, x is an element of real numbers. And that's our domain. The range, for the range, I want to start at the bottom and go upwards. So I can see that my graph begins here at -1. So y is greater than or equal to -1. And because this, again, as I pointed out, goes upwards and to the left here, I have no upper limit. So I'm just going to get rid of that. And this would be the range for that guy. This one over here is a little bit easier. I can see right away for the domain that I'm between -2 and 2. Those are my x values. So x is between -2 and 2. And x is an element of the real numbers. And I put it in those squiggly brackets, the braces. And now if I get rid of that so we can see it a bit better, for y, it's between 0 and 2. That's my y-axis. So 0 and 2, y is an element of the real numbers. And there you have it, domain and range for those guys.